Hello everyone, this is MD Asif here. I was one of the remote intern in the remote internship opportunity provided by Iaeste. My project was to design an autonomous flying taxi for Uber using CAD. This is a short video presentation where I'll present my work, what I have done and learned, as well as what I have experienced and discovered through this experience. I was nominated by Iaeste China as I'm currently studying aeronautical engineering at Nanjing University of Aeronautics and Astronautics in China. I was accepted by Iaeste Bangladesh, and my employer was the College of Aviation Technology, where my supervisor was Mr. Shuman Sharkar. My heartfelt thanks goes to Iaeste China, Iaeste Bangladesh, College of Aviation Technology, and my respected supervisor for their guidance and cooperation. In this short presentation, I'll talk about my work, what was actually my everyday task flow, my experience, what I have gained from this short internship, and what discoveries I have made with this short internship experience. So, as I have mentioned, that my goal was to design an autonomous flying taxi for Uber using CAD. I actually focused on designing electric autonomous vertical takeoff and landing vehicle, which is in short we can say eVTOL, electric VTOL vehicle. The design software package I used is CATIA, and I used the version 5 R20. From 1st September to 8 October, I actually worked for this project, and the conceptual design phase actually was till 22nd September from 1st September. After that, I analyzed the computational fluid dynamics, and which was from 23rd September till 2nd October. The CFD analysis software package I used was ANSYS, the version R16.2. But before all of that, as I had to design flying taxi or autonomous flying taxi, so as it was a VTOL aircraft, so definitely there's a wing. So for choosing the wing profile, I used Xfoil software, which is open access and provided by MIT. So at first, when I was deciding which wing to use for my UAV, I compared some of the profiles in Xfoil, and finally I had chosen NACA 747-A315 airfoil, and I analyzed the lift coefficient versus the drag coefficient. I also analyzed the lift coefficient versus the angle of attack here, and I basically decided that yes, I chose the NACA 747-A315 for my wing. Although at first I thought to use NACA 747-A315 for my fuselage design actually, but later on I decided to go for NACA 4424 for the actual fuselage of the UAV, because NACA 4424 has the thickness is higher than the NACA 747-A315. So you can also see here that the lift coefficient versus drag coefficient graph, and also the lift coefficient versus the angle of attack graph. This is the one for NACA 4424. Later on, I started to work on the surface design process in CATIA. Before I actually focused on the part design in CATIA. I have really never worked in surface design workbench, but in this internship I actually focused on surface design, which is actually more critical than the part design. So after finishing the wing profiles, I actually made this model using the CATIA, and it took almost 2.5 weeks to complete it. And you can see here that the hidden profile are the places for the payload area volume, and you can see the parachute and also the electronic speed controller and other stuffs, including battery. In the wing, the hidden parts are actually the ribs. In the zooming view, you can see that in the wing, which is similar to an ACA 747 AC-15 that I showed you before, and the spars are along the span of the wing, and the ribs are perpendicular to that in the wing. This is actually the full model of the UAV that I designed for this 5 weeks, and you can see the fuselage, the wing, and also for the vertical takeoff and landing, I have 4 rotors that I actually made from scratch, and also similar to that, I also have the one for the thrust, which will actually follow the mission statement of Uber to go at a speed of around 120 kilometers per hour or 130 kilometers per hour. After the design was finished, I actually had to do the CFD analysis so that I can know that yes, I can assure that this design will work and will actually fly. So the first thing about CFD analysis was to do a perfect mesh. Of course, the meshing can be better and better, but I tried to do my best here, which I have actually did with triangle mesh, and took care about the fineness of the mesh in the complicated regions. After that, I have the velocity flow contour. You can see that this model, in the upper surface of the model, there is a higher flow velocity. That actually means that this will create lift, because according to Bernoulli's theory, that if the upper surface of the wing has higher velocity compared to the lower surface, then the upper surface will have lower pressure. So as a result, the lower region or the lower surface of the wing will push the upper side of the wing, and it will actually create the lift. You can see that this is another velocity contour, and if you compare this data with the previous one, you will see that the velocity increased. This is because this specific model is actually inclined at 5 degree and 5 degree angle of attack, and as a result, the velocity increased, which actually means that the lift generation in this 5 degree angle is also higher compared to when the model is actually at 0 degree. This is the pressure contour model in ANSYS, and you can see that the stagnation point, or the highest pressure point of the model, is at the leading edge of the fuselage, which is theoretically that's plausible, and that should be the thing here, because stagnation point should be the highest pressure region. And on the wing, you can see that there is quite less pressure here if we compare to the next photo, and you can see that the pressure difference here is much higher, which actually confirms that there will be lift. So in my everyday tasks, I actually follow the design ideas that my supervisor suggested, which is actually I used for my primary design. But apart from that, I still had to look up for multiple other conceptual designs of VTOL UAVs and get an overall idea from them, how the wing and the fuselage connects, how the rotors are actually designed, because there are actually a lot of calculations for the rotor selection, which I actually simplified the design process and tried to maintain the design in a way that it's manufacturable, easily manufacturable. Getting the ideas and integrating them in a single conceptual model were actually the easy part for me, as in CATIA it was quite easy for me, but implementing them together in CATIA was a bit challenging task for me, because the connexity because the connectivity error is a must to avoid in CATIA surface design workbench, which I actually faced multiple of times during designing, and I have been, even though working in CATIA for more than a year, but in most cases I only worked in product design workbench, which is comparatively easier than surface design, and I'm glad that I had to use surface design for my internship, as all the major automotive or aircraft manufacturing companies use this exact workbench of CATIA. After the design phase was done, I focused on CFD analysis in the ANSYS R16.2 version, and this actually worked as moment of truth to me, because after the analysis was done, then I could really tell myself that yes, this specific design would really work. So the meshing of the full model was a complicated task. I used triangle focused meshing with a good convergence, as I told you before, and a refined mesh according to the model I worked on, and the fineness of the meshing was carefully handled in the complicated regions. I previously have not done any CFD analysis on a full model, maybe part of the model, maybe just the wing, but not the full UAV model. So actually in this case I actually simplified the UAV design, like cutting out the rotors, because if they are static, then they'll just create a drag, not showing the actual results. So I simplified the model. So after the analysis was done and I saw the results actually verified the theories and gave positive results. So I was actually so glad that I cannot express in words. The only problem I faced during this time, though, was not getting a single body in the ANSYS from CATIA, because when I transferred the CATIA IGS or IGES file in ANSYS, it was not taking as a single body. So I had to go back to CATIA again and fix the model in specific regions where there was a connectivity error. And I had to do it actually multiple of times before I finally got it right. So ultimately, with the self-motivation and time management, I have finished the work with given timeline. Even though during my internship I had online classes of my university, because the semester also started at the start of my internship, so I actually had to go through these tasks even though I had classes. So I actually had to manage my time, and through all these tasks I have learned quite a lot actually. Well, to talk about the experience of Iaeste internship, remote internship, not only I had to find and study many resources for design and CFD analysis, but I also had to work on making a report on a market study of future Uber Air services. My supervisor actually helped me a lot to go through this process, because as an engineering student, market analysis or the prediction of the market was actually quite new to me. So I had to understand the mission statements of Uber Air, or what they are going to do, what they have plans, and understand the common reference models, the CRMs of Uber Air, which they have only 3, and talk about the supply chain management and the skyports design, etc. I had to correlate multiple papers together to support the convictions of Uber Air white paper, which was published probably in 2013, and get to know a couple of similar projects of Uber Air as well. Also, I got to learn about Elevate Cloud Service, the ECS of Uber, that will basically manage the airspace management when the vehicles will be in operation. They will actually use big data, artificial intelligence, and like live monitoring of the vehicles, live monitoring of the pilots, etc. So all in all, even though the internship might be just 5 weeks duration, but I learned Uber's vision about a VTOL vehicle and ride-sharing project, and designing an UAV from the scratch for conceptual and preliminary design phases. Moreover, as I'm an engineering student who is interested in research and development, this internship really made me feel like a design development engineer. So I really enjoyed the experience, and I hope to apply this knowledge what I have gained in this internship in future. Basically, the discoveries I have made, I really thought about what are the work processes I have completed. I have been going through what are the steps. So I think that my critical thinking ability and problem solving skills have been improved through this internship, because the whole process was not so smooth. From designing till field analysis, I got stuck at different places. But with patience and diligence, I came up with a solution to ultimately achieve the end goal. Of course, in each of the steps, when I got stuck, my supervisor helped me a lot. But I guess we both had to think about the steps we got stuck in. So one of the new things that I had acquired from this internship was the thinking about the manufacturability. I actually, before the design, I actually had to go through some resources about the manufacturing options of this specific design. I also got to know about the manufacturability from them. So keeping that in mind, I actually tried to design and validate at the same time for completing the design project within shorter time. Well, how it changed my views on study is actually one of the other lessons that I have got from this internship. The 5-week internship has actually confirmed one of the vital lessons about study, in my personal opinion, is that to get the fundamental level of knowledge on everything, which will ultimately make the path ahead easier for advanced level knowledge or work. Because of my familiarity with CATIA for over a year, courses provided at my university, such as engineering graphics, introduction to CAD/CAM, already prepared me for the internship tasks I had to complete. Moreover, I am so lucky to have Mr. Shuman Shokar as my supervisor, who guided me in every aspect of the internship and clarified my conclusion every time. So that was it. I hope you enjoyed the presentation, and take care everyone, and stay safe. Thank you.